This is the final chapter of our journey through the SOLID principles. In the last part, we explored the interface segregation principle, where we learned to keep our interfaces clean and relevant to the needs of each client. Today, we will wrap things up with the dependency inversion principle, often referred to as DIP. The dependency inversion principle states that the high-level modules should not depend on the low-level modules. Instead, both should depend on abstractions such as interfaces or abstract classes. But what exactly are the high-level modules and the low-level modules? High-level modules are the big picture operations which contain the core business logic or the decision-making processes. They define what the system should do, while low-level modules are the components that handle the execution of tasks and focuses on how the system achieves what is defined by the high-level modules. Let's understand this with a real-time example. Imagine you are the manager of a hotel and you make the decisions about how the hotel should operate. But you don't directly clean the rooms or prepare the food. Instead, you have the staff members who specialize in those tasks. You give the instructions to them and they handle the specifics. Similarly, in coding, if the manager, who is representing the high level module here, starts depending on the details of room cleaning or the food preparation, then any change in the cleaning process or menu would directly disrupt the manager's work. And to avoid this, the manager relies on the roles like housekeeping or the kitchen staff. These roles define what needs to be done but not how it's done and act as abstractions. Now, let's try to bring this concept into our FTS hotel management system and depict this in our code. Since our hotel has recently opened, we are offering multiple payments methods like credit cards, PayPal, and the wallet payments. Now, to implement this in our code, let's create a class payment processor, and inside it, let's create all the available payment methods. For the credit card, let's create public process credit card payment, and let's console write line processing credit card payment like this. And for the other available payment methods, let's copy this, duplicate here, and this one is for PayPal here also, again duplicate, and this one's for the wallet, process wallet payment, and same here, wallet. At the first glance, this works fine, but there's a major problem. Let's understand what that is. This payment processor class you see here is the high level module, and it directly depends on the low level details like credit card, PayPal, and this wallet payment methods. So if we add a new payment method like let's say Google Pay, we'll need to modify this class, and this is going to violate DIP, as the DIP states that the high level modules should not depend on the low level ones. And to fix this, we will use the dependency inversion principle. As the solution lies in the statement itself, we'll create an abstraction that defines a contract for all payment methods, and both the high level and low level modules will depend on this abstraction. So let's define an interface that all payment methods must implement. Interface payment method. And for processing the payments, let's create payment process. Now, this interface is going to act as a bridge between high-level modules and the low-level modules. It defines what needs to be done, but not how it's done. And now, let's create classes for each payment method. First one is credit card payment. It should implement payment method. And let's just copy the implementation from here and paste inside it. Now similarly, let's copy this, paste here. This time it is going to be for PayPal, and just mention PayPal here, and again paste for the wallet payment, update wallet here, and done. Now, let's refactor the payment processor to depend on the iPayment method interface instead of the specific payment methods. Let's remove this, create a private field, iPayment method, payment method. Let's create a constructor for payment processor, payment, and assign the payment method with the payment method. Now let's define a public method process that is going to trigger the payment process, and inside this method, payment method, payment process. Now this call is going to delegate the task of processing a payment to the payment method object, which can be any class that implements the iPayment method interface. Like we have here, PayPal, wallet, credit card. And now the payment processor class is relying on abstraction completely. It is not dependent on how the payments are processed. So, if a new payment method like Google Pay needs to be added in our system, we can simply create a new class that implements iPayment method without altering the payment processor class or existing payment methods. Hence, our system is now ready for future growth without risking the existing functionality. All thanks to the dependency inversion principle. We have now completed our journey through the SOLID principles using the FTS Hotel Management System as our guide. I hope these lessons empower you to design clean, maintainable, and scalable systems in your projects. Thank you for joining me on this journey, and as always, keep coding and stay solid.